Welcome to STEM Education with Olufemi. I'm excited to have you join our community where we make STEM topics accessible, engaging, and fun to learn. Today, we're diving deep into one of the most fundamental topics in algebra, quadratic equations. Our mission is to explore 5 powerful methods that will give you the tools to solve any quadratic equation you encounter. By the end of this video, you'll have mastered factoring, completing the square, the quadratic formula, the square root method, and graphical solutions. Each method has its own strengths and ideal use cases. Whether you're a student preparing for exams, someone refreshing your algebra skills, or just curious about mathematics, this comprehensive guide will build your confidence and understanding. Let's begin our mathematical journey. Our first method is solving quadratic equations by factoring. This elegant technique transforms complex equations into simpler, solvable forms. A quadratic equation is a fundamental concept in algebra that appears everywhere in mathematics and science. Understanding what makes an equation quadratic is essential for solving many real-world problems. Let's start by defining exactly what a quadratic equation is and examining its key components. A quadratic equation is any equation that can be written in the standard form: ax squared plus bx plus c equals 0. This is called the general form of a quadratic equation. In this equation, a, b, and c are constants called coefficients. The coefficient a is the coefficient of x squared, b is the coefficient of x, and c is the constant term. There's one crucial requirement: the coefficient a must not equal 0. This condition is what makes the equation quadratic. If a equals 0, the x squared term disappears, and we would have a linear equation instead. Now, let's look at some concrete examples of quadratic equations to see how they appear in practice. Our first example is 2x squared plus 3x minus 5 equals 0. Here a equals 2, b equals 3, and c equals negative 5. Our second example is x squared minus 4 equals 0. Notice that a equals 1, b equals 0 since there's no x term, and c equals negative 4. Here's another example. Negative 3x squared plus 7x equals 0. In this case, a equals negative 3, b equals 7, and c equals 0 since there's no constant term. Now that we understand what quadratic equations look like, let's discuss what it means to solve them. Solving a quadratic equation means finding the values of x that make the equation true. These values are called the roots or solutions of the equation. These x values have several names. They can be called roots, solutions, or zeros of the quadratic equation. All 3 terms refer to the same thing: the values that satisfy the equation. Understanding quadratic equations is the foundation for learning the various methods to solve them. In the following sections, we'll explore 5 different techniques for finding these solutions. Method 1 for solving quadratic equations is factoring. This powerful technique involves expressing a quadratic equation as a product of 2 linear factors. Factoring works by finding 2 numbers that multiply to give the constant term and add to give the coefficient of the middle term. Let's see this in action with our first example. We need 2 numbers that multiply to 6 and add to 5. Let's think. 2 times 3 equals 6 and 2 plus 3 equals 5. Perfect, so our factors are x plus 2 and x plus 3. Now we have our equation in factored form. This is where the zero product property comes into play. This property states that if the product of 2 factors equals 0, then at least one of the factors must equal 0. Now we solve each factor separately. From x plus 2 equals 0, we subtract 2 from both sides to get x equals negative 2. From x plus 3 equals 0, we subtract 3 from both sides to get x equals negative 3. Let's practice with another example to reinforce the steps. Consider the equation x squared minus x minus 12 equals 0. We need 2 numbers that multiply to negative 12 and add to negative 1. We need 2 numbers that multiply to negative 12 and add to negative 1. Let's try. 3 times negative 4 equals negative 12, and 3 plus negative 4 equals negative 1. Perfect. So we factor as x plus 3 times x minus 4 equals 0. Applying the zero product property again, we get x plus 3 equals 0 or x minus 4 equals 0. Solving these gives us x equals negative 3 or x equals 4. These are our 2 solutions. The factoring method is efficient when the quadratic can be easily factored. Remember the key steps. Find two numbers that multiply to the constant term and add to the middle coefficient. Write the factored form, apply the zero product property, and solve each factor for x. Now we'll explore the completing the square method, a powerful algebraic technique for solving quadratic equations. The goal of completing the square is to rewrite our quadratic equation in the perfect square form, x plus h all squared equals k. Let's work through an example. We'll solve x squared plus 6x plus 5 equals 0 using the completing the square method. Step 1, we move the constant term to the right side of the equation. Subtracting 5 from both sides gives us x squared plus 6x equals negative 5. Step 2, to complete the square, we take half of the coefficient of x, which is 6, divide by 2 to get 3, then square it to get 9. We add 9 to both sides of the equation. Step 3, the left side becomes a perfect square, x plus 3 all squared. The right side simplifies to 4. Now we have our equation in the desired form. Step 4. Taking the square root of both sides gives us x plus 3 equals plus or minus 2. Remember, when we take the square root, we must consider both positive and negative solutions. Step 5. Subtracting 3 from both sides gives us x equals negative 3 plus or minus 2. This gives us our two solutions, x equals negative 1 and x equals negative 5. We can verify these solutions by substituting them back into the original equation. The completing the square method follows these 5 key steps. Move the constant, add the square of half the coefficient, write as a perfect square, take the square root, and solve for x. This method works for any quadratic equation and is especially useful when the quadratic doesn't factor easily. The third method for solving quadratic equations is using the quadratic formula. This is the most powerful and universal method that works for any quadratic equation. Here's the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Use the quadratic formula when factoring is difficult or impossible, when other methods don't work easily, or for any quadratic equation in standard form. Remember, the quadratic equation must be in standard form. ax squared plus bx plus c equals 0. Let's solve this example. 2x squared plus 5x minus 3 equals 0. First, we identify the coefficients. A equals 2, b equals 5, and c equals negative 3. Now we substitute our values into the quadratic formula. X equals negative 5 plus or minus the square root of 5 squared minus 4 times 2 times negative 3, all divided by 2 times 2. Let's simplify step by step. 5 squared equals 25, and 4 times 2 times negative 3 equals negative 24. Negative times negative 24 becomes positive 24, so we have 25 plus 24. 25 plus 24 equals 49, and the square root of 49 is 7. So we have x equals negative 5 plus or minus 7, all divided by 4. This gives us two solutions. For the positive case, x equals negative 5 plus 7 over 4, which equals 2 over 4, or 1/2. For the negative case, x equals negative 5 minus 7 over 4, which equals negative 12 over 4, or negative 3. Remember these key points when using the quadratic formula. Carefully substitute the correct values, pay attention to negative signs, simplify step by step, and remember that you'll always get two solutions unless the discriminant equals 0. The square root method is a powerful technique for solving quadratic equations, but it only works in specific situations. Let's explore when and how to use this method effectively. The square root method applies when your quadratic equation is in one of these two special forms. X squared equals k, or x plus h quantity squared equals k. Let's start with our first example to see how this method works in practice. Our first example is x squared minus 9 equals 0. This fits our first form perfectly once we rearrange it. First, we add 9 to both sides to isolate x squared. This gives us x squared equals 9. Next, we take the square root of both sides. Remember, when we take the square root, we must include both the positive and negative solutions. So x equals plus or minus 3. This gives us two solutions, x equals 3 and x equals negative 3. Both values satisfy our original equation. Now let's look at a more complex example involving the second form. Our second example is x minus 2 quantity squared equals 16. This is already in the perfect form for the square root method. We take the square root of both sides directly. The square root of 16 is 4, but we must include both positive and negative values. So x minus 2 equals plus or minus 4. Now we add 2 to both sides to isolate x. This gives us x equals 2 plus or minus 4. This gives us two solutions, x equals 2 plus 4, which is 6, and x equals 2 minus 4, which is negative 2. Before we finish, there's a crucial point about the square root method that you must always remember. Always remember the plus-minus symbol. Every positive number has two square roots, one positive and one negative. Forgetting the negative root is one of the most common mistakes students make with this method. The square root method is efficient and straightforward when your equation is in the right form. Just remember to always include both the positive and negative square roots in your final answer. The fifth method for solving quadratic equations is the graphical method. This visual approach helps us understand the solutions by plotting the quadratic function and finding where it crosses the x-axis. The graphical method works by plotting the quadratic function y equals ax squared plus bx plus c on a coordinate plane. The solutions to our original equation are the x-intercepts, which are the points where the parabola crosses the x-axis. Let's start with our first example, x squared minus 4 equals 0. We'll graph y equals x squared minus 4 and find where it crosses the x-axis. First, we set up our coordinate system with x and y axes. Now we plot the parabola y equals x squared minus 4. Notice how this parabola opens upward and crosses the x-axis at 2 points. The x-intercepts occur at x equals negative 2 and x equals positive 2. These are our solutions. We can verify negative 2 squared minus 4 equals 0 and 2 squared minus 4 also equals 0. Our second example is x squared minus 2x plus 1 equals 0. This will show us a case where the parabola touches the x-axis at exactly 1 point. We plot y equals x squared minus 2x plus 1. This parabola just touches the x-axis at 1 point, which means we have exactly one solution. The parabola touches the x-axis at x equals 1. This is called a repeated root or double root. We can verify 1 squared minus 2 times 1 plus 1 equals 0. Our third example is x squared plus 1 equals 0. This will demonstrate a case where the parabola never crosses the x-axis. We plot y equals x squared plus 1. Notice that this parabola is shifted upward and never touches or crosses the x-axis. This means there are no real solutions to the equation x squared plus 1 equals 0. The graphical method reveals 3 possible cases for quadratic equations. A parabola can cross the x-axis at 2 points, giving 2 real solutions, touch at 1 point, giving 1 repeated solution, or never touch the x-axis, giving no real solutions. The graphical method provides visual insight into quadratic equations and helps us understand why some equations have 2 solutions, 1 solution, or no real solutions. This method is particularly useful when combined with graphing technology. We've explored 5 powerful methods for solving quadratic equations. Let's quickly review each approach and see how they work together to give you a complete toolkit for tackling any quadratic problem. Method 1 is factoring, where we break down the quadratic into 2 linear factors. Method 2 is completing the square, transforming the equation into perfect square form. Method 3 is the quadratic formula, the universal solution that works for any quadratic equation. Method 4 is the square root method, perfect for equations without a linear term. Finally, method 5 is the graphical approach, where we visualize the parabola and find where it crosses the x-axis. Each method has its strengths and ideal use cases. Practice is key to mastering these methods. Try solving different types of quadratic equations using each approach to build your confidence and speed. If this video helped you understand quadratic equations better, please give it a thumbs up. Your likes help other students discover this content. Don't forget to subscribe to STEM Education with Olufemi for more mathematics tutorials, problem-solving strategies, and educational content that makes learning fun and accessible. Keep practicing these methods, and remember that mathematics is all about building understanding step by step. Thank you for watching, and I'll see you in the next video.